Hello, 9 Briggs and 9 Bernoulli students. We will now go to our new lesson, which is all about systems of equations or systems of linear equations. This is our topic in analytic geometry for week number 8. So we're now through with the different forms of linear equations, and we also learned how to find the distance between a point and a line. So systems of linear equations, or solving systems of linear equations by graphing, elimination method, and substitution method. Let's start with graphing. A system of linear equations consists of two or more linear equations. It can be two or three, but in this topic we will focus our attention on two equations solved simultaneously. So this section focuses on only two equations at a time, and the solution of a system of linear equations in two variables is any ordered pair that solves both of the linear equations. Example: determine whether the given point is a solution of the following system. The point is -3, 1. Okay, determine if this point is solution to x minus y equals -4 and 2x plus 10y equals 4 by substituting the values of x and y to the two equations. X is -3, y is 1. So plug the values into the equation first. For equation 1, x minus y equals -4. We have -3 minus y is equal to -4. Yes, true. For equation 2, 2x plus 10y equals 4. 2 times -3 plus 10 times 1 is -6 plus 10, still 4, equals 4, true. So -3, 1 is a solution for solution to both of the given equations. So it produces a true statement in both equations. It is a solution. Next, example: determine whether the given point is a solution of the following system. Point 4, 2. Is 4, 2 a solution to 2x minus 5y equals -2 and 3x plus 4y equals 4? Let's check. Plug the values into the equations. First, for equation 1, 2 times 4 minus 5 times 2 is 8 minus 10 equals 2. Equals -2, should say. Is it correct? True. 8 minus 10 is -2. For the second equation, 3x plus 4y equals 4, we have 3 times 4 plus 4 times 2 equals 12 plus 8, 20. Is 20 equals to 4? No. So for 3x plus 4y equals 4, 4, 2 is not a solution. Only first equation. So since the point 4, 2 produces a true statement on only one equation, it is not a solution. Meaning, for it to become a solution, the two it should produce a true statement in the two equation, not only one. Yes. So since our chances of guessing the right coordinates to try for a solution are not that high, we'll be more successful if we try a different technique. And since a solution of system of equations is a solution common to both equations, it would also be a point common to the graphs of both equations. So to find the solution of a system of two linear equations, graph the equations and see where the lines intersect. So let's start how to solve a system of linear equation by graphing. Solve the following system of equations by graphing. Number 1, 2x minus y equals 6 and x plus 3y equals 10. So what will you do here? First, you draw the lines. You draw the graph of the two lines and see where the point of intersection is. So for 2x minus y equals 6, we have here the graph. Right? We have learned how to find its x and y intercept. X intercept is 3. That's right. And y-intercept is -6. Correct. Diba? X-intercept is -c over a. And y-intercept is -c over b. Or you can use the intercept form. Divide all terms by 6. So that's 6 dyan. Tapos ito, 6 divided by 2 is 3 equals 1. So you can see x-intercept is 3. Y-intercept is -6. So for the second equation, yes, y-intercept 0, negative 6, x-intercept 3, 0. Okay, another point. So for the graph of x plus 3y equals 10, we have 10 thirds for the y-intercept and 10. Okay, 10 for the x-intercept. Yun. Dito, dadaan siya sa 10, 0. That's the x-intercept. While the y-intercept is 10 thirds or 3.3 here. 3.3. Therefore, the point of intersection between these two lines is this point, yes, which is at 1, 2, 3, 4, 2. Therefore, the solution, the lines appear to intersect at 4, 2. Okay, parang, di ba? So, let's continue. So, although the solution to the system of equations appears to be 4, 2, we still need to check the answer by substituting x equals 4 and y equals 2 into the two equations. Check natin to verify if 4, 2 is really a solution to the two equations, or the what we call the system of equations. For the first equation, 2 times 4 minus 2, 2x minus y yun, di ba? 2x minus y equals 6. Is it true? 8 minus 2 equals 6. Yes, that's true. For the second equation, 4 x plus 3y equals 10. So 4 plus 3 times 2 6. 4 plus 6 equals 10. 10 equals 10. That's right. So therefore 4, 2 is a solution to the system, or the point 4, 2 checks, so it is the solution of the system. Example another. Solve the following system of equations by graphing. Negative x plus 3y equals 6 and 3x minus 9y equals 9. So first let us graph. Negative x plus 3y equals 6. X and y intercept. For the x intercept, negative 6. For the y intercept, 2. Yun, tama, diba? Y intercept 2, x intercept negative 6. How about for the second graph? X intercept 3, y intercept negative 1. Oh, diba? Negative 1. And for the y intercept 3, 0. Okay. So what is the point of intersection between the two lines? Parang wala, no? They are parallel. Parallel lines do not meet. So I think there is no solution for this system of equations given. So the lines appear to be parallel. So although the lines appear to be parallel, you still need to check that they have the same slope. You can do this by solving for y. So for the slope, what is the slope of this? Negative a over b lang. Negative 1, 1/3. Ito naman, negative 3 over negative 9, 1/3 pa rin. So they have the same slope, therefore they are parallel, 1/3. Yes. They have the same slope, which is 1/3. He used the slope intercept form. I used the yung formula for slope, negative a over b sa general form. Negative a over b dyan, no? Negative 1 over 3, 1/3. Negative 3 over negative 9, 1/3. Yes. So both lines have a slope of 1/3, so they are parallel and do not intersect. Hence, there is no solution to the system. So parallel lines do not have a solution. Another example, solve the following system of equations. X equals 3y minus 1 and 2x minus 6y equals negative 2. First, graph x equals 3y minus 1. Yeah, that is the graph of x equals 3y minus 1. Because if you solve the x-intercept, negative 1, 0. For the y-intercept, ano siya? Positive 1/3 dito, 1/3. For this graph, okay, x-intercept negative 1 din dito. Y-intercept positive 1/3. Positive 1/3 din. So I think they coincide. So in Ilocano, tinapalda na. Coincide sila, they coincide. The lines appear to be identical. So Although the lines appear to be identical, you still need to check that they are identical equations. You can do this by solving for y. So first equation, x equals 3y minus 1. 3y equals x plus 1. Okay. Right. The equation is y equals 1/3 x plus 1/3. Second equation. Okay, they are the same equations. So the two equations are identical. So the graphs must be identical, and there are an infinite number of solutions to the system. All the points on the line. So all the points on the line are the solutions of the system of equations. Marami siyang equations. Sa parallel lines, there is no equation. So intersecting line, there is one equation. Pero dito, if they are identical, then there are infinite number of solutions to the system. So there are different types of systems. There are three possible outcomes when graphing two linear equations in a plane. One point of intersection, so there is one solution. If the lines are parallel, there is no solution. If they coincident lines, so there is an infinite, or there are infinite number of solutions. So if there is at least one solution, the system is what we call, or what we consider to be consistent. If the system defines distinct lines, the equations are independent. Right? There is one solution, consistent. If the system defines distinct lines, the equations are independent. Now, change both linear equations into slope-intercept form. We can then easily determine if the lines intersect, are parallel, or the same line. Example, how many solutions does the following system have? Okay, write each equation in slope-intercept form. For the equation 1, 3x plus y equals 1, we have y equals negative 3x plus 1. For 3x plus 2y equals 6, 2y equals negative 3x plus 6, divide both sides by 2, y equals negative 3 halves, x plus 3. The lines are intersecting lines since they have different slopes, so there is one solution. So if two lines have different slope, that means they will intersect. But if they are parallel, but if they have the same slope, they are parallel. Yes. Now, how many solutions does the following have? Excuse me. So how many solutions does the following system have? For number 1, 3x plus y equals 0 and 2y equals negative 6. Okay, answer. What's your answer? 10 seconds. Solve the slope to determine the number of solutions. So how many? First, let us determine the slope. Write these two equations in slope-intercept form. For the first equation, y equals negative 3x. For the second equation, divide both sides by 2, y equals negative 3x. Okay, they are both identical, so it has many infinite solutions. There are infinitely many solutions. Okay, they coincide with each other, so identical, tawag dun. About this, how many solutions does the following system have? 2x plus y equals 0 and y equals negative 2x plus 1. Write each equation into slope-intercept form. For the first equation, y equals negative 2x. For the second equation, y equals negative 2x plus 1. As you can see, they have the same slope, which is negative 2. So, the lines are parallel. The two lines are parallel, same slope, but different y-intercepts. So, there are no solutions. There are no solutions because they are parallel lines. Alright, we are now through with system of linear equations by graphing. Let us also proceed to another method of solving systems of linear equations. This is called by substitution. So the substitution method, another method can be used to solve systems of equations. It's called the substitution method. You solve one equation for one of the variables, then substitute the new form of the equation into the other equation for the solved variable. Example, solve the following system using the substitution method. 3x minus y equals 6 and negative 4x plus 2y equals negative 8. So solving the first equation for y. Okay, transpose or subtract 3x from both sides, becomes negative y equals negative 3x plus 6. Multiply both sides by 1 or divide both sides by negative 1. It's the same. Yes, multiply the equation by negative 1, so it becomes y equals 3x minus 6. So this new form equation, okay, here y equals 3x minus 6, we will substitute this in the second equation. Substitute this value for y in the second equation. Negative 4x plus 2y equals negative 8. So substitute y by 3x minus 6. Yun. Negative 4x plus 2 times quantity 3x minus 6 equals negative 8. And then distributive property, negative 4x plus 6x minus 12 equals negative 8. Negative 4x plus 6x is 2x minus 12. Negative 8 plus 12, 12 both sides. Negative 8 plus 12 is 4. Divide both sides by 2 is 2. Okay. So na-solve na natin yung x, y na lang. Solve natin. How do we solve for y? Substitute x to this equation. Y equals 3x minus 6 to solve for y. Here. Substitute x equals 2 into the first equation, solve for y, which is 3 times 2 minus 6. 6 minus 6 is 0. So therefore x is 2, y is 0. Our computations have produced the point 2, 0. So this is now the solution, but still need to be verified or checked. So check the point in the original equations. So for the first equation, 3x minus y equals 6. 3 times 2 minus 0 equals 6. So 6 minus 0 is 6, true. For the second equation, negative 4x plus 2y equals negative 8. Negative 8 plus 0 is, okay, true. So therefore the solution of the system is 2, 0. Solving a system of linear equations by the substitution method. So these are the steps. Solve one of the equations for a variable. Substitute the expression from step 1 into the other equation. Solve the new equation. Substitute the value found in step 3 into either equation containing both variables, and check the proposed solution in the original equations. Okay, so another example for the substitution method. Solve the following system of equations using the substitution method. Y equals 2x minus 5 and 8x minus 4y equals 20. So there is a ready equation here to be substituted to the other equation. The value of y is 2x minus 5. Yes. So we have here 8x minus 4y equals 20. Substitute y by 2x minus 5, which is 8x minus 4 times the quantity 2x minus 5 equals 20. Distributive property, 8x minus 8x plus 20 equals 20. 8x minus 8x is 0. 20 equals 20 equals 0. So how's this? When you get a result like the one in the previous slide, that is obviously true for any value of the replacements for the values. This indicates that the two equations actually represent the same line. So I think there are an infinite number of solutions for this system. Any solution of one equation would automatically be solution of the other equation. This represents a consistent system, and the linear equations are dependent equations. So ito yung so graphical method tayo na nag-coincide. They are identical. So consists of many infinite solutions. So pag naging ganito ang solution natin. Okay. Another, solve the following system of equations using the substitution method. Okay, solve the first equation for y. Negative y equals negative 3x plus 4. Y equals 3x minus 4 by multiplying both sides by negative 1. Okay, substitute y equals 3x minus 4 to equation 6x minus 2y equals 4. So 6x minus 2 times 3x minus 4 equals 4. Distributive property, 6x minus 6x plus 8 equals 4. 8 equals 4. Simplify the left side. Then, what will happen if we have solved the equation like this? In the previous example, 20 equals 20 equal, pero dito it's not equal. 8 is not equal to 4, right? So what do you think is this? When you get a result like the one on the previous slide, that is never true for any value of the replacement for the variables. This indicates that the two equations actually are parallel and never intersect. So ganon. Pag nag-solve ka ng system of equations na ganito ang result, 8 equals 4 using substitution method, right, parallel. Pero pag equal yan, 8 equals 8, that means it has infinite solution. Pero pag ganito, 8 equals 4, that means parallel lines sila. There is no solution to the system. This represents an inconsistent system even though the linear equations are independent. So we're now through with elimination and graphing method, graphical method, and substitution method. Let's go now to the elimination method, solving system of linear equations by elimination. Another method can be used to solve systems of equations called addition, arithmetic, or elimination method. So you multiply both equations by the numbers that will allow you to combine the two equations and eliminate one of the variables. Solve the following system of equations using the elimination method. 6x minus 3y equals negative 3 and 4x plus 5y equals negative 9. Multiply both sides of the first equation by 5 and the second equation by 3. First equation, okay, yes, I will multiply equation by 5 so that it will become 30 minus 15. Dito naman, multiply by equation so that this will become 12 plus 20, so that y will be eliminated, the variable y will be eliminated. So equation 1 becomes 30x minus 15y equals negative 15. For the second equation, multiply by 3, 12x plus 15y equals negative 27. So that from here, we're going to add two equations here, 30x minus 15y equals negative 15 and 12x plus 15y equals negative 27. We can cancel out negative 15y and then add 30x and 12x, negative 15 and negative 27. Combine the two resulting equations, eliminating the variable y. Yan. 30x plus 12x, 42x, negative 15 plus negative 27, negative 42. Divide both sides by 42, negative 1. So x equals negative 1. Let us now solve for y. Substitute the value of x into one of the original equations. So you can choose each one of the two original equations. So I choose 6x minus 3y equals negative 3. 6 times negative 1 minus 3y equals negative 3. Negative 6 minus 3y equals negative 3. Negative 3y equals negative 3 plus 6, or negative 3, yes. Negative 3y equals 3. Divide both sides by negative 3, negative 1. So our computations have produced the point negative 1, negative 1. Okay, to verify, let us check the point in the original equations. So for the first equation, 6x minus 3y equals negative 3. 6 times negative 1 minus 3 times negative 1, is it equal to negative 3? True daw. Because negative 6 plus 3 is negative 3, correct. For the second equation, 4x plus 5y equals negative 9. 4 times negative 1 plus 5 times negative 1, is it equal to negative 9? Let's see, negative 4 plus negative 5, yes, it's equal to negative 9. So the solution of the system is negative 1, negative 1. Next example, another. So these are the steps in solving a system of linear equations by elimination method. Rewrite each equation in standard form, eliminating fraction coefficients. If necessary, multiply one or both equations by number so that the coefficients of a chosen variable are opposites. Add the equations, and then find the value of one variable by solving equation from step 3, and find the value of the second variable by substituting the value found in step 4 into either original solution, and last step, check the proposed solution into the original equations. Another example, how about this? 2/3 x plus 1/4 y equals negative 3 halves. 1/2 x minus 1/4 y equals negative 2. Okay, by the looks of it, we can now eliminate y variable. Okay, but first, okay, Let us first multiply both sides of the equation by a number that will clear the fractions out of the equations. Clear natin yung fractions. Let us get rid of the denominators here. So what is the LCD for equation 1? 12, diba? Dito naman 8. So 12, multiply the equation 1 by 12. So it becomes 12 times 2/3, 8x plus 3y equals negative 18. For second equation, 1 up multiply by 8. Eh, 12? Bakit 12? Okay. Pwede rin yung 12. So that becomes 6x minus 3y equals negative 24. Which can still be, ano yan eh. Dapat 8, no? Okay, continue. Pwede rin. Just continue, okay? 6x minus 3y equals negative 24. So, combine the two equations here. So, 12 para maging yun. Para ma-eliminate natin yung y agad. So, that pareho silang 3y and negative 3y. 8x plus 6x, 14x equals negative 42. Divide both sides by 14, negative 3 ang x. So after solving for x, substitute the value of x in one of the original equations. So let's choose 8x plus 3y equals negative 18, negative 24 plus 3y equals negative 18, negative 18 plus 24 is 6 divided by 3, 2. So our computations have produced the point negative 3, 2. X is negative 3, y is 2. Then check the point in the original equations. Note, here you should you should use the original equations before any modifications to detect any computational errors that you might have had. Yes, we must use in checking the original equation, not the modified equations. So third x minus plus 1/4 y equals negative 3 halves. Substitute x by negative 3 y by 2. Right, from here magiging negative 1 plus 1 up. And negative 2 plus 1 up. Negative 2 plus 1 up, is it equal to negative 3 halves? True. For the second equation, 1 up x. Negative 3 halves minus 1 up naman yan. Is negative 2 equals negative 2. True. So the solution is the point negative 3, 2. Okay, special cases. In a similar fashion to what you found in the last section, use of elimination method to combine two equations might lead you to results like 5 equals 5. Which is always true, thus indicating that there are infinitely many solutions since the two equations represent the same line. Or 0 equals 6, which is never true, thus indicating that there are no solutions since the two equations represent parallel lines. Thank you very much for listening. This is Systems of Linear Equations using the graphical method, substitution method, and elimination method. I'll see you in part 2. Goodbye.